Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey listeners, you've again found your way back to Making Data Simple. I thank you for that. I enjoy doing the podcast, and I'm just thrilled that we actually have listeners out there that take the time, part of their day, learn about technology. I'm really excited today. Got somebody on that I've been wanting to talk to a while, and that is Dr. Ruchir Puri, who is the Chief Scientist of IBM Research and IBM Fellow. He's a Vice President of IBM Corporate Technology. I have had several client discussions with Ruchir. He knows his stuff. He doesn't mince words. He tells it like it is. I've not met a question that he can't answer, but maybe we'll try to get to one today. He has led IBM Watson as its CTO, chief architect from 2016 to 2019. He's held various roles in technical research, engineering leadership across AI and our research business. He's a fellow of IEEE. He's been an ACM distinguished speaker and IEEE distinguished lecturer, and he was awarded in 2014 an Asian American Engineer of the Year. I'm going to continue and then I'll pause, but he's also been an adjunct professor at Columbia University, a visiting scientist at Stanford University. He has 70 patents and has authored over 100 scientific publications on software, hardware automation methods, microprocessor design, and AI algorithms. I'm going to stop there. The intent is to talk about AI, maybe some quantum. We're going to keep it simple, but we're going to have some fun. But before I even jump into that, thank you, Ruchir, for being here. I appreciate it.
Oh, thank you. And thank you, Al, for the kind introduction. I really appreciate it. We should get right to the topic. Nothing excites me more than technology, both on the work and off the work, actually. So.
All right, great. We're going to do it. Hey, but before I do, I've got a habit of always letting you introduce yourself. What's your experience? What's your passion, and what brings you to today?
So my passion has always been about, I think, really pretty much since I was a child. My passion is about making. So I would describe myself as a maker. Interestingly, I think it was Anderson Horowitz who said in 2011, software is eating the world. So it doesn't matter whether you're doing hardware, software, you're doing software actually, because everything is software defined, everything is software built. Even if you are building some form of CNC machines, you are building, diagrams and you're feeding it, pretty much you're programming things to build things. But I love to build things, and that's truly my passion. The other passion I have is hiking. I love to hike, actually. And the third one, which I think most people who know me also know, is collecting baseball caps. And I have literally a massive collection of them, actually. So that's a couple of things that really excite me. So
Let's start from the bottom. Yeah, I see you on YouTube. You do a really good job of social. Kudos on that. You are always wearing a baseball cap. So most of the time you have a vest on too, but you always wear a baseball cap. How did you get into that habit?
it's I think it's pretty much started with the habit of, so it sort of connects my two passions together. One is on hiking. So we used to go, obviously, we go to a national or international park as a major vacation every year for last, I would say, 2 decades. Me and my wife just became empty nesters last fall. So it's been almost since the kids were very small. We've been going on hiking trips, and it was always a problem on, you go to a hiking trip, what to get, and so on. Is it like you always find baseball caps, and that's how my sort of collection started, if I may say it. And I really love nature, and it's a very nice thing. And you will typically find me wearing baseball caps that are sort of from national parks or nature. It always has a nature theme on it. So it's really started with my passion of hiking and collecting stuff that reminded me of wonderful hikes, which resulted in, hey, I have this big collection. I should wear this collection, actually. So,
well, the thing I like about it now is now we go visit a client and you still wear the hat. They're not going to change who you are. You've got a
I
hat everywhere you go.
this is interesting. People almost think I was born with it, but I will not change it for anyone.
Good for you.
I could be with there are many opportunities to be with CEOs. I don't change. Well, you are who you are. Actually, there's nothing you need to change. Actually.
So, what is your brand though? Because as I started the podcast, I said, look, I've not met a question that you can't answer. I know you to be AI. I pulled you into a client discussion on quantum. I mean, you killed that. Where's your brand? I mean, is it just technology? I mean, is there any limits?
But they're always. I think you are always learning. It's if our brain is a model, which obviously our body is a machine, and your brain is certainly a
He's thinking
active
AI
learning
already.
model. it
Yeah.
it has limits, for sure. It has limits, but I think I put it this way: you are always learning. And yes, my passion is technology. I've been lucky enough to work at almost every level of abstraction of technology. I remember within a couple of years, when I joined IBM Research at the basement in IBM TJ Watson Research Center in a lab. I was radiating chips with alpha particles to see how they fail. So this was, you start with pretty much at the basics of the technology and you proceed up from there. I've designed circuits, I've built microprocessors, I've built software to design microprocessors. I've, you head up. I've written books and papers and built products on accelerating workloads on hardware like GPUs and others, and then really led Watson and beyond. So I've been lucky in many ways. I call myself nothing but lucky to have been able to experience and contribute across the depth and the breadth of the entire IT stack, if I may say it that way. And that, in many ways, puts me in a lucky position in many discussions to be able to connect things as well. But of course, everybody has their depth in a certain area, and I'll call mine in algorithm.
What is well? You maybe just answered the question I was about to ask. But in that IT stack, what do you love most, or what have you loved most? Is it algorithms? Is it AI now, or is it you say, nah, the good old days of building transistors, whatever? What's your first love?
Love in technology, I would really call it algorithms, actually. So optimization
Yeah.
techniques. And AI is a class of a optimization technique. The way these machines learn, it's an optimization method through which they learn. It's basically gradient based optimization methods. And so if you just step back and say all of these class of techniques are broadly speaking in the domain of algorithms, and that's what my passion always has been, including pretty much right from my very right from my grad school days when I did my PhD. It was on algorithms, and I've been applying it to different applications, if I may say it that way. I was applying algorithms to design chips, because designing chips is like there are billions of transistors. Think of that as a massive graph that you're trying to optimize. You need to reduce the size of it. You need to really make sure it consumes less energy. So there are different cost functions through which you are designing them, but nobody can design these by hand. So there's a lot of talk these days on automation. There's how to design these things with automation as well. It was always about these optimization techniques and software. That's exactly what I worked on always. And that's and then I've been applying that to AI and beyond as well. And so there's a cross-cutting theme, I would say, which is what intersects everything.
So, how are you spending your day currently? I mean, what do your days look like currently?
So one thing I've always made sure, Al, that and actually for most people who know me know this, that I protect my time on. I sort of We started this discussion as who am I? I'm a maker. I protect my time on making sure, despite the fact that you are leading large teams and you're chief scientist and this and that, you stay sort of you remain true to your sort of what excites you. Because one thing I would say very plainly and honestly as well, Al, what happens in sort of there is a, I would call it a derailment factor for technical leadership. People become too much of a leader and less technical.
Hmm.
Which is, you know what I'm saying, that like,
Yeah, I know
people are,
exactly what you're
they're
saying.
presenting all the time, they're talking, then they start talking about other people's material, and then they don't exactly like you. More you go, if I may use the word, up on
Yeah.
a sort of a technical ladder, the more they are asking you to kind of broaden out. But it's critical for a technical leader to be balancing the technical and the leadership part out. And since technology is moving so fast, that being technical means you are playing with the technology all the time, because that helps you connect things and tune what I'll call, for a technical leader, I call it a BS meter actually. That somebody comes to you and tells you, hey, this, and this, you should have a sense of, yeah, kind of sounds right. I think I can believe it, to be able to ask the right questions as well. And
Yeah.
that to me has always been critical to me, which is, to make sure I'm spending the time. Obviously, it's asked of me, demanded of me to spend it on the leadership side. Hey, you're talking to clients, you're representing IBM, you're talking to, being in conferences, but make sure I'm always involved closely in defining what comes next in technology. And to do that, I need to be closely in touch with technology as well, because I can't just define things in isolation. And we'll have more discussions on AI, what sort of how all of the stuff we are doing on generative AI came together. But to me, it is critical for me personally to balance out the leadership and the technical part, and I kind of divide that equally, if I may say, between the two, to ensure we are being grounded, and as leaders we are not just kind of spinning things, if I may say it that
Well,
way.
so I lied. I got to ask you a follow up now. How do you do that? I mean, with all the demands, do you divide your calendar up to like 4 hours of research, in depth learning, 2 hours? What? How do you tactically achieve what you're talking about?
Yeah, so typically, I would. So one thing I've always, for a long time, every day there are big blocks put, but typically every Friday, the entire afternoon, and because that leads into the weekend as well. Because if you're passionate about the technology, I said, both on the work and off the work, that's what you're thinking about a lot. So typically all afternoons on Fridays it blocked, so it starts that, and then it kind of, if I'm doing some reading, that carries over into the weekend as well. But obviously you're balancing it out with your family life and others, but with almost 3-4 days you are giving it enough attention, because comes, Monday or something, things ramp up on other activities. But for me, I have, my, certainly my assistant knows this very well, I protect that time very vigorously. And then, once you decide what you are going to experiment with, what you're going to play with, hey, there is this app I want to build, then you can start connecting that over rest of the week. You find 1 hour here, you sit down and you block things. So there are things that are blocked in the calendar sort of on an intermittent basis, but then they are blocked in the calendar from a pretty much from 12 onward, all the way into the obviously the weekend. That gives me good enough time to focus on things and think through what comes next actually, but also gives me the time to experiment with things as well, on what should be my next experiments be.
Great advice. Great advice for the technical leaders out there. Okay, let me jump in. So I'm an IBM fanatic because I work at IBM. However, in the podcast, I try to be as agnostic as possible. So I want to start with the tough one. And here it is. I was reading the news yesterday. True story. I'm reading the news. It happened to be Morning Brew. I'm just call it like it is. And at the very end, I get to the end. It says something like the AI hype. This isn't the first time for AI hype or something. And then it has a link, a brief history of IBM Watson. So, I can't avoid that. So then I hit the link. It talks about IBM beating the most successful Jeopardy contestants in 2011. Yeah, we know that. And then it talks about IBM held the know-it-all question and answer robot as a game changer for all sorts of business applications from healthcare to digital advertising. And then it goes on to say that results were decidedly mixed when it comes to delivering on some of these promises. And then it goes on to say, well, like other companies, IBM has announced a refresh for Watson that will place it in the midst of another AI hype wave that we're in right now, which is a new AI platform called WatsonX. So my question is one, are the criticism of the original hype fair? And then secondly, why is this time different?
So I would say I'll answer the question on Watson pretty much head on. Actually, I would say we were very successful at handling certain use cases through which we made tremendous progress on natural language processing. We did, because we demonstrated, obviously, in Jeopardy, for a machine to be able to answer nuanced questions is quite phenomenal, which excited, the society at large. In the process, I think I'm just talking about IBM now, and I'll answer the question on sort of the AI hype broadly. I think we challenged ourselves to some of the toughest tasks known to mankind. I would say solving cancer.
Yes.
There are just too many things that are involved as part of it. This is like really some of the toughest challenges facing humanity. And to me, there are very practical uses of the technology, like, to be able to help customers, all of us actually, in customer care. I think that, I would argue, has been a very successful use case, demonstrated by rampant, obviously, and broad adoption of AI technology in customer care scenarios. You can machines can understand your speech very well now, and there are very practical use cases even from the past wave as well. And I would argue, the product we rolled out, which started from the Jeopardy time, Watson Assistant, has been one of the most successful products that we have had, with responsible for very large business. For us, it was always about, not just about, I would say, consumer part of it, but how enterprises consume AI, and trust was a significant part of it. So I would say some of the criticism of, I would say, Watson is warranted, because we kind of challenged ourselves. Let me say, there's nothing wrong in challenging, by the way. If we don't challenge ourselves as technologists, we are not pushing hard enough. So we pushed ourselves very hard, but it is a very hard problem as well to be able to solve cancer. Of course, maybe as humanity, we would like to solve it. But they were, on the other hand, we were also pushing some very successful use cases as well, which have been which have reached broad adoption to among enterprises in every industry you can look at. So I would say, really, I would push back on some criticism, and I'll accept some criticism as well, in saying yes, we challenged ourselves too hard. And where certainly some criticism is valid. But on the other hand, I will also say, if we are not pushing ourselves too hard, then we are not pushing, the limits of the technology hard enough. Now I'm going to talk about the broader part of the AI. I do believe when we started with Jeopardy, if you look at the last wave, actually, of sort of the winter of AI, that really excited, I will call that time in 2011 the beginning of the current wave of AI. It's gone on for more than a decade now, almost. And it's definitely clear this time it is different. And people will argue, yeah, everybody will say this time it is different. But if you look at the likes of OpenAI as example, the most recent version of it, OpenAI and ChatGPT, and you know, when literally billions of people can get hand on it and they can get excited about it, that was never the case before. It was always in the realm of academia. It was always in the realm of research labs. It was always in the realm of a few companies. Now, literally billions of people can touch and feel it because of the scale of the technology and how far it has spread. And I think majority of the people will agree the experience they are having this time around is different. I think anybody can go and try it out and say, yeah, this really sounds very different. And the way you are able to interact with machines in seamless, natural language way is so fundamentally different than what it was there before, which was kind of put together, if I may say, in a very highly engineered systems. This is very generalized now, which is what is fundamentally different about this wave. And I don't think I'm understating this in any way. When governments are starting to really wake up and look at this, there won't be a. If you went to World Economic Forum in Davos, this was the topic for what is happening in the society these days. So I don't think there's always hype. It's just the nature of the technology. There will be a hype and then it'll settle down, but it's going to settle down at a plateau, and then again go up as well, but at a plateau which is significantly higher than where we were last time in terms of how far it'll push the limits of the technology.
So let's double click on that a bit. So, what do you think is still hype? And what do you think over the next 3 years we're really going to see in terms of real deliverables?
So I would say, one thing I don't worry about, and probably there's just too much written on this. I believe if you call it a hype or if you call it somehow people are scared, the machine's taking over. We are nowhere close, actually, nowhere close to it. Because to be fair, these machines have some level of reasoning, but not enough actually. That we need to worry. They are learning from the material, but they truly do not understand the if I may use the word context reasoning, logical reasoning, deductive reasoning, all of that combined, and they are not multimodal. Only when you become like a human being, you don't learn only by reading text. You learn by absorbing the world around you in a visual way. You learn by almost like being in the presence, like you and I can be in the presence of each other. We don't have to say a word. We learn by expressions. We learn in many different ways, and I call it multimodal. Actually, the word, these machines had to become significantly multimodal and to be able to reason and understand enough to get to anywhere we are talking about, where there's a lot of social media on, machines taking over the world, and we need to worry about existential threats. That I do believe is hyped up. I sincerely believe that is hyped up. And again, I cannot predict the future, but I really do not think that's going to transpire in any time soon, if at all, actually, because we'll always have regulations around things, and governments are starting to wake up to govern this technology. Um, that's one part I really believe is kind of hyped up. The other is, I also always believe that anytime there is such exciting technology, there is hype around, it becomes kind of a magic bullet. Hey, here is I have a problem, apply generative AI to it, it's going to solve it. I do believe it's going to solve tremendous number of use cases which are pretty phenomenal. But I do believe the euphoria on just a rampant amount of money that's floating around to solve every use case, with the magic generative AI being a a easy button, if I may say it. Solving real problems requires putting solutions around a core technology. Just like all other technologies that have preceded before it, that's going to take hard work. Solving problems that are focused and in context going to require LLM or large language models or foundation models or generative AI is part of a solution, not the entire solution in itself. Which is where I think we need to come to the reality of it.
But why now? In that, is it because now we have AI with large language models, generative AI, plus data, plus the compute to support that? Is there any one of those equations that you could take out? Is there any significant element that I'm missing that it brings this to this culmination of where we find ourselves today of this transition in AI?
I would really say this particular revolution rests on three major foundational pillars: data, compute, and algorithms. Those three things sort of magically came together to give rise to this latest wave of technology. And I would double click on data and say it used to be the case 5 6 years back with deep learning that a lot of label data was required, which actually is manually intensive, and this is why the ramp up wasn't as fast as the latest wave of technology. Because what has happened with the most recent algorithms in the case of AI is what is known as transformer architectures. Without going into the detail of it, from a data point of view, they learn from data which is sort of unstructured, if I may say it. It doesn't have to be labeled data. They basically learn from documents as you just need to point them to the pretty publicly available data or private data. They learn, they absorb it, and they learn from it in a sort of unsupervised way, which helps enterprises scale the AI without the need for tremendous subject matter experts painfully labeling the data and teaching machines, which is not scalable. It allows the latest wave of AI with generative AI to be able to scale things. And then that, since now you have access to tremendous, literally petabytes of the unstructured data, you're going to need a lot of compute to crunch that down as well, which is this which is no, in that wave. Obviously Nvidia, the company on the west coast, who has the computes that resulted in a lot of those breakthroughs, GPUs, they've been beneficiary of it. But you need a lot of those matrix computation processing engines, linear algebra processing engines, to be able to crunch the data, this petabytes of data. And then new techniques came together from a software point of view, which is these algorithms that help together to merge these two efficiently, to train the machines and result in these generative AI models like ChatGPT and others, which truly open the door for some wonderful use cases to be solved, from customer care to AI writing software and code, to security and many others as well.
Let's pivot, but still stay on the same subject. What's IBM's solution then, and how is it differentiated from others in the market?
So I call it, I'll call it very transparently and openly. If the current sort of landscape of technology in the AI area was a triangle, there are obviously three sides of that triangle. First side of that triangle, I'll call it OpenAI, Microsoft, ChatGPT, which is, I almost call it, obviously there's a saying in English, my way or the highway, which is you are doing this and this is all you're doing. We've got it all solved. There's a closed model. We won't tell you what data we used. We won't tell you, kind of what how many parameters are in this model. Just trust us. This is all okay. Okay, that's
But
one
all
side.
right, so just pause for a second though. I got to the first try. Isn't that risky though? And we won't tell
Exactly.
you what data. I mean, maybe you were going to go into that, but before you get to the other sides, that gives me caution, and I think that's why some of the people out there are fearful. Could you make a comment on that?
Exactly, and this is where I was going to in terms of the other sides of the triangle,
Okay, go
which
ahead.
is that is very risky, precisely the point, Al. And this is why majority of the enterprises are very scared. Like, I have no idea. And there are, I mean, you, I, many others actually are in every client discussion goes to this topic,
Mm-hmm.
which is like, what data was used? Is it license approved? Is it copyright approved? No, like, what am I putting my business at risk for? That today, let's say I designed a product with it, and tomorrow my product is at risk, right? Well, this will be too late for me to correct it because I would have lost time, money, and trust, which is critical to businesses actually. So I think this really goes to the heart of the worry that enterprises have. I'm, as a user, maybe okay, like, I want to write a poetry for my let's say daughter's like birthday coming up. It helps me do that. This is wonderful actually. I don't have a problem. That's okay actually. But as an enterprise, when you are really using this within your enterprise, you have a real worry, which is exactly goes to the crux of that problem that we are sort of that defines our differentiation from an IBM perspective. Now let's go to the second part of that triangle. I will say the second part of the triangle is Google. Now, I think most of us will agree. For the first time in their lifetime, Google is on a back foot. To be fair and to give credit to Google, majority of this technology called transformers came out of work that was done originally at Google. Ashish Vaswani, who did the work on attention is all you need, among the five authors, he was the leading author of it, and he has since left Google. But they were kind of taken off guard with this, and now they're trying to sort of result back. But their approach is also either you are here or you're nowhere else. Actually, trust me, we've got this covered. And what data you used, I don't know. We won't tell you. What do you do with my data? I'm not very sure. We kind of use it, but I'm not very sure. We can give you some options. It's confusing actually, and this is exactly where enterprises go to. So the third part of that triangle, third side of the triangle, I'll call it open. Even interestingly, there are many influential AI players who are innovating in AI tremendously aligned around that. IBM is one of them. Meta is another one. Meta has done some wonderful work in open source AI models. And companies like Hugging Face, which have become the largest marketplace of AI models in the world. Let me give you a simple statistics. Um, you know, since ChatGPT was introduced in last October, 200,000 AI models have been put on a marketplace of Hugging Face. 200,000.
Wow.
That's the speed of innovation that is taking place. And I usually say it, Al, that on that side of the triangle, you've got these big companies who are aligned along with 100,000 some of the smartest graduate students in the world.
Mm-hmm.
One thing I've learned painfully so is you don't try to fight out really hungry and smart graduate students, because they all need to graduate and they're going to innovate the hell out of it. So this is the collective power of the intellect of the community, which is aligned on that side. So on one side is this proprietary stuff, with my way or the highway. The other side is Google on doing something things with Bard, and the third side is massive innovation taking place. And I'll just give you a quick example of it, Al. There was a leaked memo from Google recently, which actually said, you know, this was within Google actually, and this was leaked out somehow. But like, we don't have a moat, and neither does OpenAI. And the article was about how fast is the open movement catching up to some of these proprietary models. And now I'm going to connect it to our strategy actually, which is what are we doing, what is our differentiation. So our hypothesis is following, Al. The hypothesis is every use case is going to need its own domain data to learn from. Think about it this way. If you are an IT automation expert, if you go to ChatGPT, it does a decent job, but decent is not good enough. If you are trying to do something and automate something, I need a pretty high level of achievement on it. I need experts in that domain. And if I'm going to automate it with another generative AI technology, I need a high level of accuracy for that task. I don't care about writing poetry for my daughter. I don't care about my dog, my cat. I don't care actually. I really care about that task. For example, if you're trying to migrate your legacy code written in COBOL to Java, I care about COBOL to Java. I don't care about 100 different things or 2 million different things it can do. So that gives rise to the base model on top of which it is built has to be good enough. It doesn't have to be, I can beat my chest on, look, I'm 0.1% better than you. It doesn't matter, because lot of that domain expertise and the expertise of the model will come from your domain data and your expertise on it, which is really your data, your industry and domain knowledge and so on. And that is where majority of the benefit of the use case comes from. And the base AI model has to be good enough. So we believe it is not going to be about one model that rules all, but it's going to be about specialized models that are trained out of a good enough base model, which open communities innovating the hell out of, and then fine tuning, prompt engineering, and prompt tuning the models on top of it to apply to enterprises in all kind of different scenarios, from security to IT automation to customer care and beyond.
Does that mean I'm still going to have to label data with those models?
No, not at all. In fact, that's the entire advantage of these foundation models, that they actually can absorb the data, they can learn from the data of your domain knowledge, which is unstructured. Think of it as documents. Let's say I'm an engineer and I've got a lot of manuals, and I want this, the generative AI models to be able to answer the questions of my engineering domain. I can inject all of those documents as is. You don't need to label anything. It's just like you will give that to an intern, or actually someone who is just apprentice, fresh out on a job. You will give it to them regarding, hey, go read these documents. You'll just do that. There's no labeling needed, which is the blessing of the generative AI technology.
Can't I, as a client, though, just go to Hugging Face, get a foundational model, and then go off on my own? Why IBM? Where would IBM come in and make the difference that Hugging Face in my own built within my own company methodology cannot compare to?
Yeah, so this goes to the data point. We are on, so our solution to this actually is called WatsonX. Within WatsonX, we are offering trusted data that we actually have collected data. We have, interestingly, I was telling this to a client yesterday. I never envisioned working with a lawyer as a collaborator daily on a daily basis in my life, actually. This is not what I went to grad school for, to work with lawyers. Actually. You only dread, actually, oh, I'm with a lawyer, or something is wrong, actually.
Yes,
Because
exactly.
it's really about trust, actually. It's not about making sure, it's about making sure that we have done the due diligence in terms of responsibility of the data sources. That's first one. So when we are collecting data, we are also curating that data, and we are also governing that data as well. And when we, within WatsonX, we will have models that are gathered from open source, but also we are building IBM supported model as well, and we stand behind these models and also the data sources that went behind them. We actually have what we call fact sheets that we generate for these models, and we have data sheets as well, which we generate for these, the data that went into these models as well. So you can trust not just the models but the data that went into those models as well, which is exactly where our differentiation comes in. And now the enterprises can trust the base on top of which they're going to build their fine-tuned models off. So our differentiation into this exactly comes from, not just the sort of studio and exploration technology we offer, but in particular it goes to the trust of AI, which goes to the trust of data and the governance of that data as well, which is what we stand behind. And that's why we were talking, Al, about the beginning of, isn't that what scares the enterprises? Like when we were talking about OpenAI, we are addressing exactly that part as a differentiation in WatsonX.
Will IBM have some of its own specialized models, or will everything be open source?
So IBM will obviously have, no, we will have open source models, but we are also building our own specialized models as well. I'll give you two examples to which I have been very closely associated with, really working and leading as well, in the area of AI to be able to write software. So, for example, there's a domain called, in the domain of IT automation, which is, as all of us know, everything is software defined. Computing infrastructure itself is software defined. And there are unique languages in that domain, programming languages in that domain. One of the language which is widely popular with the developers in this domain is called YAML, YAML, also interestingly called yet another markup language. And this is one that, skills are very hard to find. So we have developed a model which actually is able to generate code from natural language. You can type things in English in your VS Code developer environment, wherever you are, where you develop your code today. You can say minus name, colon, English thing, and then press enter, and it'll actually return the code in that YAML language, which is not, not everybody, a lot of people know Python or Java or things.
Hmm.
That language, not the skills go very deep actually. So it's able to produce that code for you in IT automation context. We have a model for that. We are bringing that out as part of a product. We have Watson Code Assistant. Second one we are working on is, for example, legacy languages, which have obviously, 95% of the financial and the government systems run still on a legacy language called COBOL. To be able to take that and to be able to translate that into modern languages, that's another one that we are offering. Other models that we are building, which in natural language, to be able to summarize enterprise tasks actually within the context of enterprises. So several specialized models we are also building together as well as part of it.
If a client is thinking about, well, should I go test out OpenAI and ChatGPT and see if I can add to that, but then there's risk in the data, what deciding factor should they make for my future around AI?
So first, I would really say, and this goes to the risks of AI as well. There is no substitute, Al, for due diligence on the use case. That still holds true whether you are using old models or new models. Don't think of this as, the silver bullet to be applied to anything you want. You have a problem, here is a generative AI for that solution. Think about the use case very carefully. Once you have the use case in hand, then it becomes very important that, now you want to make sure. The whole point about foundation models is that's why they're called foundation models. Rather than building one model for every use case, as was the case in the past, a decade back, you are now building these models on top of a base model, which is also called the foundation model, which is generalized, but you can fine tune this model to accomplish multiple tasks. You need to make sure that underlying foundation models is governed and was built with trusted data, which is where truly our differentiation occurs, because the foundation models we are offering as part of WatsonX, already several models released as well, are built with trusted data. Then you need to make sure the fine-tuned model as they are built, your data doesn't go into somehow training the underlying model as well, which is one of the biggest worries of enterprises, which is somehow their data gets leaked to this, big daddy of all models. Interestingly, there was a case of Samsung somehow leaking their confidential information to OpenAI, and it showed up on somebody else's desk, which is Samsung's confidential information. That is something that worries all regulated industries. First of all, every enterprise, but it scares the hell out of all regulated industries, because then they'll be in violation, by the way, of privacy of data as well, not just their own data, but their customers' data too, actually. Which is obviously, as you know, goes to, there are huge actually implications of that from government perspectives and others. So we are really going to the heart of what I'll say, the trust and the responsible part of data and AI, and bringing the best of tuning and training technology, along with specialized model that solve some particular pain point use cases, for example, for digitization of enterprises, like application modernization, like IT automation, like obviously customer care and others.
When I talk with a lot of clients and I'm explaining our strategy, similar to what you've done, one question that was asked, I mean, look, I answered it, but the customer kept asking the same question, so I must not answered it well. They would say, "Hey, look, I got you, but ChatGPT has 175 billion data points. What you're talking to me in the model that we're describing, Al, is around 250 million data points. How can your model, Al, be as proficient as 175 million data points? They just have more data points. Surely they're more efficient and optimized than you just by the amount of data parameters that they have. How would you answer that?"
So the way I will answer it is following way. Those 175 billion parameters, enable it to be very generalized. It has ingested pretty much every part of the public data known to mankind, every bit that is available on the web, it ingested it. And to ingest that much of general data, it needs large number of parameters to fit it, to be able to become a very strong general model, actually. Having said that, what it doesn't have is that sort of specialized part of the model, which is, I'll give you example of, we just discussed it in the morning in our WatsonX rally today. um, this, I'll give you concrete example, actually. The language translation from this legacy language, invented in mid 1960s, called COBOL, to Java. The model that we have is a 350 million parameter model. We are competing with a model that is 175 billion parameters. So you're talking about something that is 500 times smaller in terms of the size of the model. Let's now talk about the accuracy. The accuracy of the model, and I'm talking about, you take a COBOL program, you translate it into Java. There are two steps now. You compile that Java program so as to be able to run it. Then once you are able to run it, you need to make sure the test you had, which is this input, this should be the output, they pass as well. So the accuracy numbers I'll give you is what we call runtime accuracy. You run the program, it run all the unit tests that you had for originally the spec of the program. Now, the chat gpt version of that program basically gives you 18% accuracy, 18.
Mm-hmm.
The version that we have, which is highly tuned, trained with really specialized governed data, purpose built for doing that task, actually, is 95.9% accuracy. And I'm doing really apples to apples comparison at this point for that task. So you're looking at something that's 18% versus 95.9% accuracy. And this is where I go back to, if focus on the use case, focus on the task. Because you focus on the task, you can become very efficient in terms of the size, and you can be much better in terms of the accuracy. We have similar experiments on the case of like IT automation as well, as an example. So it's a question of not just, I call it, interestingly, I call it jack of all trades and master of none,
Mm-hmm.
which is what these models are. They are jack of all trades, they can wow you, but they really aren't master of anything. Enterprises need mastery of a certain domains, actually, and which is what these sort of highly tuned models are able to give you. Of course, you need a good enough base. You don't have to have the best base possible, because a lot of value comes on top of that base.
Do you, well, in this manner, in the way in which IBM are bringing, in the way that IBM is bringing these models to market, are we alleviating hallucinations?
Because of the fact, also, first of all, I think some of the hallucination is inherent in the technology. So the multiple ways in which we are eliminating it. One of the ways we are eliminating it is because we are narrowing the scope down. We have guardrails around things. So first of all, there are multiple ways we are doing to be responsible in terms of sort of AI deployment. um, First of all, we have guardrails. So we have sort of controllers at the output, if I may say it that way, which actually help you make sure that you don't go off rails in terms of profanity, PII data, all of that stuff, actually, which we filter in the output, input training data, and we also have outputs related to it. The other is, because you have scoped your use case to certain narrower tasks, the potential possibility of hallucination also goes down, because we are having what we call content grounded dialogue. It's grounded by certain content versus free for all the entire internet. We are grounding the dialogue in a certain content and say answer based on this content only, and then it just can't. Obviously, there's always a possibility of it generating things that may not be necessarily only in that content. But if you prompt it with the right stuff to say answer based on this content, that's exactly what it's going to do, actually. And if you are asking generic question to a open AI model, you can ground it in anything. Actually, you can. It's like it's going to answer whatever it has knows from the entire web. Actually,
That makes sense. Before we break, can you say a few more words on WatsonX? Because WatsonX actually is three parts. WatsonX.ai, it's WatsonX.data, which I think you've referenced along the way, but you've also got WatsonX.governance. What, why those three pillars, and how do they fit together?
so I'm really glad you brought this up, Al. WatsonX is a platform. I think we talked a lot about data. Data capability brings together a state of the art, highly performant data store where literally petabytes of this data goes. It can be queried with natural language interfaces. The data can be discovered seamlessly. It can be governed seamlessly as well, and so on. That goes into our data connects to our AI capability, which is a we talked a lot about models, open source models, some of the IBM curated models that are available as part of it, and also a studio for exploration and fine tuning and prompt engineering and prompt tuning of those models as well. So just think of it as you got some base models, now you want to bring your own data, you want to tune on top of it. All of that capability is available in our AI studio. And then finally, I think this is, I would argue, one of the most important part, which is governance. Once you have developed the AI model, significant part is the governance of that AI. Where did the data for the model come from? Who touched the model last? When has it been deployed? What accuracy it has? Has it been drifting? When the model is deployed, has it been drifting? All of that part on the trust and the responsibility of AI resides in governance. So we've got capabilities in data that connects to AI, which connects to governance, and these three pieces are the foundational pillars of a state of the art generative AI platform for the enterprises, which enables us to offer trust of data, to be able to tune right specialized models for your use case, which will be better than generalized models that are available on the net, and to be able to deploy that and govern it the right way, as well as these models are making decisions and generating content for you in real life.
And as it relates to Microsoft, I know they've made a very similar announcement. Is it really come back, the decision point really come back to your data or the internet of data? Or are there bigger factors at play between those two offerings?
Yeah, I would almost say enterprises have a choice to make. Will they bet on one model to rule all, or will they bet on a open community and the power of open ecosystem? To me, it is very simple actually. I think it's a choice you are making between the power of a open ecosystem and the power of a closed ecosystem. You want to get locked in, or you want to be continuing moving, because we are still very early in the innings of AI. We are in the beginning few years of that massive wave of AI. It's going to last for couple of decades, if not more. Now you have a decision to make. You can get logged in, and by the way, this technology is moving very fast. Today it is this algorithm, tomorrow it will be something else. And one thing you can make sure, open ecosystem will keep up with it. It is the one that is innovating at the leading edge of it. So our bet is on an open ecosystem, which is, we proved it by betting $34 billion in a company which is best of all a open company, Red Hat. And we are bringing exactly the same philosophy of open ecosystem, the power of openness and transparency. Our first bet was hybrid cloud. IBM strategy is hybrid cloud and AI. And we are betting the same on AI as well, with the power of open ecosystems.
Hey, last question. If I am a client out there listening, I have not started yet, what should their first step be?
So first of all, I would say, if you haven't started on this journey, please do. It's literally going to reshape every industry, actually. It's clear. No, I would say if you haven't, I think you should have started yesterday on this. Uh, that's my first actually urge to every client, every enterprise. Second urge will be, once you have sort of gotten your sort of thinking together on it with certain strategic thinking around it, decide the use cases, because nothing is a silver bullet. Like, okay, well, I have a problem, just apply generative AI to it. Man, that kind of approach we know hasn't succeeded in the past. I don't believe it will succeed now as well. Make sure, here are my, here is where I can get most productivity, here is where I have good data as well, here is where, this is the compute I'm going to need. Make sure you sort of flesh that out with certain well thought out use cases through which you can demonstrate to your key stakeholder the value of this technology. And third, pick a partner. And this is exactly where IBM comes in as well. We are a partner. We are not just a ware provider, actually. We've got our IBM consulting arm who knows enterprise use cases amazingly well, actually. Pick a partner who will be on this journey for you to create value and solve your problems. As I said, it's not just a question of, my way or the highway, and, here is a model that will solve all, because all problems have different flavors. So partner with someone who understands this technology, who has created, really enterprise version of this technology, and who will be there to solve the problems for you in the enterprise context, and has been on this journey with you all along.
Thank you for today, Ruchir. Where can folks reach you? What's the best place? Is it LinkedIn or is it?
Certainly, they can reach me on LinkedIn. That's the easiest way to reach me.
All you have to do, listeners, is hit WatsonX and it'll lead you right to our website. Thank you for being here, Ruchir Puri. I appreciate it. You're awesome, man. Very
thank
good.
you, Al.
Very
I
easy
really
to talk
appreciate
to.
it. It was a fun discussion.
And listeners, as always, hit us on almortontalksdata@gmail.com. Love to hear from you. We'll see you on the podcast. Bye-bye.